Hi, Constant. Are you there?
Hello, can you hear me?
Yes, actually, here's pretty good.
Perfect.
Hi, how are you?
I'm fine. Thank you for
Great,
inviting me
great, great.
to. Yeah, can you hear me? You cut out a bit. Thank
Yes,
you for
yeah. Now,
inviting
now
me
I can hear
to
you.
the
Now I can
user
hear you.
group. Yeah. Thank you for the invitation. I'm very happy
Of course, no problem.
to actually share my thoughts with you guys and answer, if I can, questions that you may have about Sagemaker, how to bring your own model, train it, and deploy it.
Great, Constant. For everybody, Constant, I'm gonna tell everybody that you are a machine learning hero. So it's great to have any additional comments at the end of the sessions. Maybe how you convert to ML hero. That is great. Something that is we're really in the need to have ML heroes here in Latin America. I think there is only one in Mexico. My kudos to Gabriel Ramirez right there in Mexico. It's great. So we need more ML heroes. Exactly, community heroes, right? So you can share with us some maybe thoughts about how you convert to ML hero at the end of the session. So actually, I ain't gonna take you a few minutes of your presentation. So please, you can introduce yourself and have a good time here.
Yeah, sure.
Please, if you start sharing your screen.
Yes. I think
Got it.
everyone can see my screen.
Of course, yes,
Okay.
you can see.
Shall I start?
Of course, the audience is yours.
Okay. Thank you guys. Thank you guys for having me. I'm Konstantinos, and today we're gonna see how we can bring our own model, custom model, to Amazon SageMaker and train it. First of all, I'd like to say a few words about myself. I'm in the working field for more than 5 years now, and the past 3.5 years I work at Orpheum as a data scientist and data engineer. My background is more of a data engineering, but then I'm a data scientist by practice. Considering the AWS, I recently, I think it's July, I joined the AWS ML Hero community, and I'm also the co-organizer of the AWS user group in Greece. I fairly post articles about AWS stack, machine learning, deep learning, and SageMaker stuff on my blog. You can see the link here. And anyone who wants to connect with me, ask any questions, just go to my Twitter and send me a personal message or a tweet or a mention or something like that. I'm more than happy to respond. So let's get into business now. Let's see how a machine learning engineer or a data scientist actually circles a machine learning problem and what is the flow that it follows. First of all, you have a problem, you need data to solve it. So the first three steps are to fetch the data, clean them, format them on your own as you please, and then prepare and transform them in order to insert them into your model, train it, do predictions, classifications, whatever you want. Once you have the data, then you have to build a model, feed it to it, train it, and then evaluate it. And do over and over again until you are pleased with the results. Once you have a result, next thing is to integrate it with the production environment, share it with your colleagues, users, through an API, a package, whatever you want, and then you have to constantly monitoring it to see if the model performs well, if you need to upscale or downscale your infrastructure. And at some point, this is inevitable, but at some point, your model will start underperforming because new data are going to come, and your model is going to see data that is not known to it. So you go the flow again. you fetch new data, you clean them, prepare them, train your model, evaluate, and so on. And this is an endless cycle. Now, let's see how Amazon and AWS can help us with this flow. The AWS machine learning stack is huge. And is mainly split into three categories: the AI services, ML services, and ML frameworks and infrastructure. The AI services is more of like plug-and-play solutions. You do not need a very good or solid data science or machine learning background to use them. I'm sorry. You already have the algorithm there. For example, for Amazon recognition, you can use it, like feed it with images and ask them to find the objects, and you'll get a response, a JSON response with the objects in the image, and that's it. So all of those services are out of the box, trained, built it for you to use it through an API, and that's it. Now moving one step forward, we go to machine learning services, where you actually have to have a data science background in order to use them. You start writing code. You need to know what you're doing with those. And here's the start of the topic of the presentation, which is Sagemaker, and it's actually Sagemaker Studio. But it's not only that. We have ground truth. We have AWS has augmented AI. It has Sagemaker Neo, which is pretty nice services. And last but not least, we have the frameworks infrastructure, which everything is built on top of. You have instances with very powerful instances with GPUs, CPUs. You have elastic inference. You have inferentia. You have deep learning AMIs and containers that you can use and build your own models and train them manually. And also it supports a lot of frameworks. And even the frameworks that Amazon does not support, you can basically build your own Docker containers and support them. So let's move on to Sagemaker. For the newcomers and the people who don't know what Sagemaker is, it's practically an end-to-end machine learning platform. It follows every single step of the flow that I show you, and it provides you with tools to ease the flow. It practically needs zero setup, or at least a minimal setup, like one click to set up the Sagemaker environment. If you do not want to do that, you can just use the Python SDK and train models from your local machine to Sagemaker. It's very flexible when it comes to training a model or processing data or deploying your models to endpoints. It has a bunch of out-of-the-box built-in algorithms. It has a bunch of supported frameworks, the most popular ones. And even if you don't find what you are looking for, you can always build it yourself and use the infrastructure and the framework of Sagemaker. And the most important part is that you pay by the second. If your model takes, let's say, 1 hour, or be more exact, 59 minutes and 24 seconds, this is how much you're going to pay for. So we're going to focus on the Sagemaker Studio ID, which is a new release. They released it on re:Invent 2019. It's a really nice addition to the whole Sagemaker ecosystem, and it comes with a very nice new tools. We're going to have a small tour, a quick tour on Sagemaker Studio on the demo, but I'll say a few words about the new services and the new tools that provides. We talked about built-in algorithms, and we're going to see them later. The new amazing stuff that they announced in the re:Invent was the Sagemaker notebooks. I used to spawn Sagemaker instance notebooks, which takes like 10 minutes to spawn, and then you have to kill it because you're getting charged for it, and then you have to reopen it. So you wait another 10 minutes and so on. Now with Sagemaker notebooks, it takes up to 5 seconds to spawn a Jupyter notebook, and that's it. We have Sagemaker experiments, a really nice, again, addition. You can monitor and see the progress of your machine learning models. the training progress. You can compare stats, value accuracy, training accuracy, value loss, and so on. There's the model tuning. It was already there, the hyperparameter tuning. One of my favorite tools is Sagemaker Debugger, where you can literally, in real time, see everything about your training process. And if we have some 1 minute at the end, I'm going to show you something very, very cool. We have the Autopilot. At first, I was a bit skeptic about that, but it seems it can be very useful. You throw a raw data set in it. You say that, okay, I want to classify or predict that column, and Sagemaker takes the data set, performs pre-process and exploratory analysis. It selects a bunch of models and run with your data, perform hyperparameter tuning, and then it spits out the best model, the best performing model. So at worst case scenario, you have a baseline. At best case scenario, it solves the problem. There's the model hosting, which is really, really nice. With like literally one line of code, you can deploy models on an API, and you don't have to set up anything. And the new thing on top of model hosting is the Sagemaker Model Monitor, which is really, really, really nice. So where it comes, the Sagemaker, how it can help you with the machine learning flow. On the first part, where you're preparing your data, there's the Sagemaker processing, where you can spin up powerful EC2 instances to process your data there. And there's the Sagemaker notebooks. On the train and evaluation, we have a bunch of stuff. We have the model tuning with hyperparameter tuning. We have the Sagemaker training, which we're actually going to see in the demo. We have the Sagemaker debugger, my favorite tool, and we have Sagemaker experiments. We're going to take a class on that too. And finally, we have the model deploy and model monitor, so you can create triggers to start the flow again, retrain your models automatically, and stuff like that. The very interesting thing here is that you're not obligated to use everything. You can pick and choose whatever you like. For example, we're only going to see Sagemaker training and Sagemaker experiments, and that's fine. This is a very nice thing about Sagemaker. Considering frameworks that supports, especially on the estimator part, which we're going to see later, is all the popular ones: TensorFlow, PyTorch, scikit-learn, MXNet. I think now they have added Gluon. There is Spark that you can spin up with MLlib, and so on. There's a bunch of options. And even if you don't find your option, you can always build your own. Considering Sagemaker's building algorithms, I've used it a couple of times. I really like to build my own models, but they're really powerful for simple cases, or even standard cases. You can use them. They're very, very fast, built on top of the AWS infrastructure to be optimized, and obviously you can take a look on those and find wherever you like. I think now there are like 18 built-in algorithms. I've lost count. There are a lot. So let's move forward to the demo. You can see here I have some might recognize the whole interface. It's something like Jupyter Lab. This is Sagemaker Studio, and you can spin up based on a kernel. You can spin up Jupyter notebooks, interactive cells, terminals. You can do markdown files, text files, whatever you want. So I have my Jupyter notebook here. And let's say my very, very specific problem, does not find a solution on the building algorithms. Because usually very specific problems need very specific algorithms and models. So here I have, I'm trying to classify images based on the content. And we're using a very popular data set, which is the fashion MNIST data set. I know this is not a specific problem, but for the sake of the tutorial, yeah. So my model is pretty simple, but let's say I want to train it for 15 million images. That needs some power. So that's what we're going to do. I have the model here. This is something that I run locally, and it works for a couple of images, like 10,000, 20,000 images, it's fine. But when it comes to a larger scale, I need the raw power of Sagemaker. So we're going to use Sagemaker Studio to train our model. Let's have a quick tour here. We have our file system here, as every Jupyter lab. We have integration with Git that we can connect our repositories and work from there. Here we can see a list of all the sessions that we have open, terminal, kernel, and running images. Be careful, because those are actually are charging me right now. The SageMaker as it is has a very, very low cost, but when you spin up instances, for example, here you can see it's not very powerful, but it costs. So be careful with those. Make sure to shut down. They spin up very fast. It's not something like SageMaker notebook instances as it was before. Some configuration for your environment, the experiments that we're going to take a closer look later. Jupyter Lab configuration, our endpoints, and our open tabs. This is pretty much it. So let's get down to the demo. Here I first install some libraries that I might need on my development environment. And I start right away. Start importing stuff. I'm using TensorFlow kernel, so everything considering TensorFlow is already installed. NumPy is already installed and stuff like that. So I'm good to go. I download my data. Let's take a closer look on the dataset. We're having 28 by 28 images in grayscale, and we have to classify them in the categories. For example, this is an ankle boot, this is a t-shirt top, and so on. And this is not very simple problem. It's not like the digit recognizer of MNIST, because you can see that the t-shirt top is very similar to dress in shapes. So it takes a bit longer to train. We do the baseline, the very standard procedure. We normalize our data, resave them, and get them ready for our model, transform all our labels in one-hot encoding, and that's pretty much it. From here, I can just run my model, but the machine that I have open here is not powerful enough, so I have to use SageMaker. It's a relatively simple process. Any questions that you might have, you can ask me. Let's get down to it. I'm importing SageMaker. As I said, it's a Python SDK. Getting my session, the session variable of SageMaker actually carries a lot of metadata for your environment. For example, you have your default bucket, where the model is saved, and so on. Our execution role, this is an actually IAM role that has access, that gives SageMaker access to specific resources. I serialize my data. This is, again, standard procedure. And now I have to upload the data to an S3 bucket. But here, the beauty of SageMaker is I don't have to get involved with Boto3 or to which bucket I have to upload it or anything like that. SageMaker has a default bucket for your environment. You can obviously change the bucket if you want to. I didn't. And we run those two lines to upload our train and test dataset. So we come up with this dictionary where it says where my train data is and where my test data is. And let's put a pin here. Now I want to prepare my model for training. And first of all, you're not obligated to create experiments and trials. I just like to monitor my models. So to start training my model, I want first to create an experiment, which for me it's bring your own algorithm meetup experiment. And there I want to run a bunch of trials. So I create my experiment. You can see it here. I create my trial, which is bring your own algorithm tutorial, let's say. Here's a very interesting thing. You can actually add a for loop and start playing with the parameters and train a bunch of models with different parameters, and everything is going to be appear here. And then you can go in and see the training accuracy, the validation accuracy, and so on, and pick and choose your best fitting model. So yeah, I create a trial, and now I'm ready. I'm ready to train my model. But first, I have to tweak my code a bit in order for Sagemaker to be able to run it. So first of all, I added to a model.py file for Sagemaker to run it. I do all the necessary imports here. And pretty much the only difference, you can ignore this, how I read my data. You can see I'll use npload because I saved my data with NumPy. But the main point here is that the only thing that you have to do is to use argument parser, because Sagemaker is going to run your model like this. When the EC2 instance spins up and everything is ready and the data has transferred to your EC2 instance, Sagemaker is going to run your model like this. So you can see that in the main function, the only thing that I use is the arg parser. And from there, it's pretty much standard procedure. My hyperparameters, I load the data, this is my model, I fit my model, and then I save the model, and that's it. So if you manage to create a template like this, the only thing that you have to change each time is your model, and maybe add or remove some parameters, but that's it. So we are ready. We have a model.py, and we are ready to train it with our data. There are two basic steps here. First, we have to create an estimator, and then we have to use that estimator to train our model. So here I'm using the Tensorflow Estimator. An estimator basically is the package responsible for spawning the instance, getting ready with your algorithm and the data, and be ready to train, and to run this command to start training. Push the logs, populate your experiment trials and stuff like that. So let's go line by line here. You'll see it's very simple. First of all, I have to define my entry point. To say actually to set to my estimator which Python file you'll have to run. And this is my model.py. Then I have to define on what instance do I need to train my model. I'm using a fairly large instance for that model, but why not? You can always check all the available instances on the Amazon's Sagemaker documentation, and you can see here everything that you need to know. I'm using, I think, that one, which is $4 per hour. It's pretty pricey. Then I define how many instances I want. I just want one instance to train it, but you can use multiple instances. And if your framework supports distributed training, then it will do it. Where I want to save my model, once it's trained, I want to save it somewhere. And this is very important because where I save my model, the estimator is going to take my model and upload to S3. And we'll see how we'll download it and play with it. I set a bunch of parameters. I want to run it for 10 epochs, and you can see it here. My batch size will be 128, and you can see it here, and my learning rate, you can see it here. So it's pretty much translating those two into arguments my model. I pass it the role. This is actually the access the instance will have to different resources on my AWS account. Yeah, it's pretty straightforward. My name, the training job name. I define my framework, my TensorFlow version, which is 1.15, and my Python version. And then I enable the script mode, which is what we're doing. We're running an estimator based on a script mode. Now, if you have a model and you're using a framework that Sagemaker does not support it, you can always build your own image. You can always build your own Docker container and train your model there. I actually have a blog post on my blog, which I go use step by step on how to create your own Docker container and train your models there. Now, the only thing left is to set the estimator where my inputs are, to what experiment I want to run, and that's it. And I run it. So you can see here, I have training. This is my trial. And once I open it, it has a bunch of charts. You can always, let's say I don't like that chart. I'm going to remove it. And I'm going to add a new chart. It's going to be a line on time with 1 minute aggregation. And I want to plot, let's say, validation accuracy. Yeah, I haven't actually exposed that metric. So let's go to Epoch. Yeah, you can see the validation accuracy here. But this is not only the only thing that you can do here. You can see the final metrics of your algorithm, of your model. You can see the parameters that you passed. Here, for example, you see that Sagemaker uses a Docker image, a TensorFlow Docker image. So that's why you can build your own Docker image and run whatever you want. The instance type that I ran it, and so on. You can see the artifacts of your model, where are the inputs, what are the outputs. Here, for example, it says is our model. And if I go to S3, you can see that I can download my model and play locally with it. It's now trained. So very good. So once training is finished, we can manually download the model, the trained model, or we can use both of three and play a bit with it. So I download my model, I extract it, I downloaded the full model, load it. You can see that this is actually my model, the one that I defined, and play a bit with test labels. It performs well. Well, we played with it. Finally, once you have your artifact, your model uploaded to S3, it's pretty much one line of code. You can instantly deploy it to an endpoint, and without having the fuss of creating an instance, setting up a Flask API or whatever API you want, make sure that everything performs well, you have no downtime and stuff like that. This is just one click, and you deploy your model into an endpoint. Well, I think this is pretty much it. I hope you guys enjoyed the tutorial. I have the same tutorial of how to bring your own algorithm in my blog also, without the experiments and trials and stuff like that. But yeah, thank you guys for staying with me.
Wow, eso ha sido increíble. That was awesome, Constant. Really, really awesome. To have a little your perspective of how you bring your own algorithm. Or I mean, it's also go bring your own container, right? So
Yeah.
actually, there were a few things happening on the chat that is just maybe they are asking and confusing a little bit because maybe you're telling something a little bit advanced, but no problem. I mean, this is a 200 talk, right? So What about telling us a little bit in easier words? What about the benefits of bringing your own algorithm to SageMaker, and, for example, comparing to take your algorithm to another cloud provider, if they have this feature or not? Maybe GCP has this feature, I don't know, or Azure maybe has this feature, or maybe this SageMaker has a specific feature, that unique feature that make you brings your own things there. What are your thoughts about that?
Yeah. So I've played a bit with Azure ML. It's more like a drag and drop pipeline. I think you can use some custom models, but it's a bit hard. I haven't played a lot though. I've played with GCP, but you'll always bring your own model in Google Cloud. But you have to set up your instance, and if it's not TensorFlow, and so on. Here, for example, let me show you some of the logs that I created while training my model. The beautiful part here is that you build by the second. You see that it starts here. It has already the data in it, setups, environment variables, and then it runs the same actually the same command that I show you, and it starts training. And when we go here on, let me see, it was the AWS settings. We built for 132 seconds, not for 1 hour, not for the manpower that I had to actually give to any other instance, even in Amazon with EC2 instance, to set up my environment, download TensorFlow, and so on. You can obviously
Oh, that's
use
great.
just Docker containers. It's as simple as that. But this comes, the whole
Yeah.
package. You can monitor your progress here. You can see stuff like that. I've used, as I said before, Google Cloud a lot, but I haven't used it for the past 2 years. So maybe things have changed a lot since SageMaker actually threatened everyone. So yeah, who knows?
Oh, but I stay in SageMaker, please. uh,
Wherever you feel
but yes,
comfortable. It's a nice tool,
actually,
but wherever you feel comfortable. Yeah.
that's the beautiful part. That's the beautiful part of doing machine learning in AWS, right? You can bring anything you want, anything that it comes in a Docker container. You can actually, I don't know how to say it, like modularize that, make modular things, and bring and deploy it to SageMaker, right? You actually have the option to right away choose whatever your, I don't know, after your champion challenge, check which I don't know, if you're making a champion challenge, right, competing multiple algorithms at the same time with multiple Docker instances, or multiple, I don't know, these hyperparameters champion challenge, I don't know, and then deploy it automatically to SageMaker endpoints and go on with that. So I'm gonna bring for this last question. I mean, this is actually for the next steps. I'm gonna join the conversation. Jenny Vega, what we're talking about a few minutes before the stream. We were talking with you and with Jenny also about the next steps of where do we go from there. Yeah, now we have the container deploy, now we have the metrics in the CloudWatch. You also have the debugger, right? You also mentioned that. So
Yeah,
that's
yeah,
just a really, I personally really interesting in the debugger, right? Because if you bring any container, and you have the option to view details about the logs and metrics and something like that. I don't know if you can show us about
yeah.
the debugger a
Actually,
little bit before
yeah,
joining. I'm gonna join.
yeah. I'm going to show you something. What you can actually do, or how far you can go with debugger. We all know the digit dataset, the handwritten digit. A guy here on the AWS examples actually set it up, the debugger, to get everything from the model. And he can actually create something like this. This is actually real time. He was getting that real time on how the model actually use all the filters, what's the weights, what neurons are fired, and what's the predicted class. This is how much detail
Oh
can
my
go
god,
debugger.
that is great.
Yeah, I haven't
Yeah,
seen.
maybe we can.
Yeah.
Yeah, maybe if we are interested, we can make a next session about debuggers and all these things. It's really, it's really opening my mind for a lot of things there.
Yeah.
Really awesome, Constant. I'm impressed with that. I never see something like that.
Yeah.
Well, we have Jenny here. Jenny, hi. You can hear us well?
Hi. Yeah, can you hear me?
Yeah, yeah, of course. Hi, hi.
Hi.
Well, Constant, I'm going to present you. Jenny is an ML engineer on Rappi. She works on Rappi here in Latin America, and is Peruvian also. And maybe she has a question of what is the next steps taken from there, from the deployment of the model. So Jenny, go on.
Yeah. Hi, Konstantin. Yeah, I have just two questions, and I think they're very important for all of us know about this. The first, what do you think are the next steps to continue developing models in AWS and even take them into production?
Yeah. Nice to meet you, by the way, Jenny. Yeah, this is a very interesting question, and I've played a bit with that. We usually have a pipeline where in our company, we get our data using Athena, AWS Athena, into Sagemaker, and then we train our model, and using debugger, we know when it was overfitted or if something broke, and if all went well, then we automatically deploy using the command. Oops. Using the command I showed here. But something that we're investigating at the moment and we're exploring is the Apache Airflow. I don't know if you guys know about Airflow.
Yeah, yeah, I know Apache. I think there are many ways that we can use to deploy models only using AWS services, but we can use open source services also or frameworks.
Yeah, definitely. Yeah, AutoML, I think they has a very nice feature, very nice tools for deploying models.
Yes, AutoML, also MLflow,
Yeah.
Kubernetes, Kubeflow. There are such a ways to do this. Thank you. And I have another question, but this
So
is a little simple. What is the minimum cost that you think we could invest using SageMaker, or what does it depend on?
it really depends on the use that you are going to do. For example, here I have my Jupyter notebook that obviously runs a kernel behind the Docker image, and I'm getting charged for it here. Um, I have the endpoint that it's ML M4 X large. I'm getting charged of it. So if I start closing everything, for example, here, if I start shutting down my kernels and everything and start deleting my models, the only thing that's left is just the SageMaker environment. And here you're getting charged just a fraction. I think it's something like 40 cents per month. Maybe they have changed that. I have to look it up, but only for the EBS and the EFS that SageMaker uses to host your data temporarily. And that's it. But it really depends on the use. If you are going to train models in, let's say, instances with 10 GPUs, it's going to be pricey.
Of course.
Here, sorry.
Okay. I think it also depends on the amount of data you are going to train, or the instance where you are going to train the models also.
Yeah, and I've seen use cases where people are going here. They have unlimited budget, and they say, "Okay, I'm gonna spawn the MLP3 16x large," and usually the GPUs are starving here, and then you have to go to something more of like a pipe mode, like Horovod or something like that, to pipe data as fast as you can to your model in order to not starve your GPUs. But you're getting charged, by the space that you're using, the instances that you're using, either on your notebooks, on your training, or your processing, if you're using the processing estimators, and the instances that you're using for the endpoints, and S3, of course.
Cool. Thank you. There are only my questions. Thank you for joining us today.
Thank you for having me.
Thanks, Jenny. That's great questions about it. Thanks, Content, too. I want to say one last thing. There's an additional questions on the chat if you don't mind, Constant.
Sure.
Gabriel is just saying if can we use SageMaker with elastic map reduce data?
Yes, you can. You can use. Actually, let me share a really nice link. The AWS examples about SageMaker has pretty much everything that you want to, try and explore. You can use EMR, you can use Spark. There is not only on training, but on your processing, there are Spark estimators. And you can also use Spark with the MLlib. It actually SageMaker supports Spark with MLlib.
Great, that's great. That's great to know. Now you also mentioned that Athena's and other AWS services also had the ability to work with SageMaker, right? And you can go with SageMaker. Actually, with this ability to bring anything to SageMaker, it opens any possibility of what can builders and open the imagination for everything. So that's actually very great to have in SageMaker. Thanks that we have SageMaker here.
Yeah.
Okay. So that's great. That's great.
I'm going to share the link on tweets. Okay.
Of course.
Okay.
I'm putting tweet and additional links. If you want to share with us, please just copy me to the private chat, and I'm gonna put it on the screen. If you have the your email or your Twitter and if you want to share your presentation afterwards, don't worry, I'm gonna share with the community too. Also, we are forgetting something. We are forgetting the questions for the community to give away those credits and talk about in the beginning. Okay.
Wherever guys, just make sure you stay till the end to grab some really nice credits. Okay.
Yes, of course. Well, if you can make maybe one question or two questions to our community, I'm gonna put it on the screen also to make sure everything.
So first of all, because I'm trying to build a community here in Greece, and usually the hardest part that we're trying to overcome is, okay, so what content should we share? What people are using in AWS in Greece, for example? What services great companies use? So we can focus on those and start, have more attendance, help the community to understand the services better, and so on. So my question to the community is, what is the next big service that you want to see in the AWS user group Peru?
Okay, that's great. Please, can you repeat the question, please, again?
What service do you want to see on the next meetup on AWS Peru?
Oh, we already mentioned that, so that's a
You already
that's a
mentioned
good
that?
question. I
Okay.
know, yeah, we were mentioned about what is actually is going to be the next possibility of talking here, but uh, well, let's see what
Yeah, and
happens.
not the next one, but in the future one. What is the most wanted service that you want to share about AWS here in Peru? I'm very interested actually to see how you guys are using the AWS stack. Recognition,
Great.
yeah, that's a huge
Oh,
topic, huge topic.
great. Yeah,
AWS recognition.
yeah. We didn't have any meetup in recognition like in 2 years ago, maybe some. I don't know. It would be great to have some recognition meetup or recognition demo here. On
Yeah,
some
yeah,
AI tools, too. We have forecast, for example, like 2 months ago, I think some AWS expert from the community of India comes here to talk about forecast, and it was really great, something really interesting, something new. It's services that we don't always hear about, and it's
yeah,
different. MR and Glue also.
yeah. That's actually something that we use it every day in my company. Glue is a really nice service. At first, when it came out, it was a bit uh, sketchy. It had some bugs, but eventually it matured, and you can use Glue to read schemas on the fly or from your S3. You can use Glue for ETL processes using Spark and stuff like that. It's very interesting.
Great. Great. We have something there. Sagemaker model monitor. What do you think about
Yeah.
that? Are you really
Um, I haven't played a lot yet with Model Monitor, but for the few things that I've saw, it's really interesting. I think you can. I have now. I think now they have added triggers to upscale, downscale your sources on your API or your API endpoint, and yeah, it's really interesting. We usually deploy our models in Lambdas with the serverless API, serverless application model.
well?
So we haven't
But
played a lot with with the deployed endpoint from SageMaker. We usually go with Lambdas.
yeah, of course, that's awesome. That's great to be. You have all working out behind the endpoints and the big EC2 instances behind the endpoint. So that's great to have all the architecture serverless from there, taking
Yeah,
from the endpoint, and everything you work is on Lambdas. So it's gonna bring some simplex. I don't know, and maybe I don't know if it makes more complex or more easily to manage when it's on lambdas, but mm,
it depends. It depends. It really depends. Yeah.
great, great. I think yeah, we have a few guys telling us. I think I'm gonna give us one AWS credit to the four. I mean to the four first one, the first uh, AWS recognition, EMR and Glue, SageMaker model monitor, and real-time analysis and kinesis. The last one is EMR, so it's like repeating. But I think the four guys who commented are really, yeah, I'm gonna give the credit for these people. Okay, so great,
Yeah.
great. I think we have to who yeah I think we have to move and introduce Jenny here to the next session. That was here's going to talk about ML ops. So it's going to be awesome to hear all about bring your own container and then move to ML ops to see what is happening next. To see how we productionalize that model that we bring with Docker containers. Okay, so I want to thank you, Constant, for all your patience here, for all your expertise that you are just sharing with us. I really love. It's really an honor to have an ML hero in Peru. So I hope the next ML hero comes in Peru too. So uh, this is like we take that from an inspiration for you and follow the same things that you do to just to be better in AWS, especially in machine learning. So I want to thank you again, and well, I think it's time for a good, very good sleep there because I think it's like midnight.
Yeah, it's midnight.
Very good. So
Yeah.
or maybe
Thank.
keep working in that ML model that is giving you headache. But I don't know.
Yeah, thank you for having me. Thank you for the invite. The honor is mine to speak. I always like to talk with community members and bond with the community. It's really nice. Thank you.
Thanks again, Constant. So goodbye, bye, Constant. It's awesome to have you here, and you're welcome to be back with wherever you want. The open of this community is open to you. So
Yeah,
thanks again,
sure.
and goodbye.
I'm going to stay on tweets. So anything you want to ask me, you
Of
can ask
course.
me there. Okay.
Oh, yeah, yeah. You can see on the screen is your. I think it's right. It's right. Your Twitter is there, right? Let me
Yeah,
see.
yeah,
Yeah, Siaterlis Constant. That's it.
yeah.
So okay, great.
Hey,
Great
thank you
content.
guys.
Really happy to have you. Bye bye.
Bye.